Hello, welcome to another video. This is the third USB power adapter video. There's a playlist or links on screen or in the description to previous ones. I'm going to need to do something else for the next video though. I don't want to be a one-hit wonder. Here is the Eaton TRUSBAC15 wall plug adapter. Let's get into it. I have an old USB-A in-wall plate adapter that charges at 10 watts max across both ports. One of the originals. It still works, but I decided to update the charging capacity of this plug, so the adventure began with 1, then 2, then 4 of these. I have 4 of these now. This is the first. First impression, wrapper rage, plastic clamshell packaging, the usual accessories, user manual, product, nothing else. No free breakfast or interesting adventures here. Just pure battery-powered device charging goodness. This is a 5-volt output device only, so total 5 amps at 5 volts. This device is 25 watt capable, and I think it's going to get there without any problems. The 25 watt is not on one port though. Well, we'll see about that. I will be looking at several different factors related to the power adapter performance and specifications. We can see the receptacle is a UL listed product, but the actual USB power supply is unlisted. As far as I can tell, it has no certification at all whatsoever. I purchased at Lowe's, and there's a link in the description as usual. The socket is a bit more expensive at $35 US. Let's see if that extra money provides any extra performance. On the scale, the USB outlet weighs 142 grams, the packaging weighs 25 grams. The supplied user manual goes over installation and basic safety instructions. It is vague on efficiency, power output, distribution of power across the outlets, voltage output, etc., so not a lot in terms of specifications. Obviously, no regulation on this part of the market. Let's get this thing installed into an electrical box and powered up. Here you can see my test box with a cut-up cord and a few ferrules on the wires to make the connections easier. All of these USB wall outlets are quite large and don't have a lot of room in the electrical box for anything except incoming wires. These aren't great for use in outlet boxes that have any extra cabling in them. These will also produce some heat, so ventilation needs to be considered as well. So one wire in the electrical box where these are to be installed, or an extra large box if you have to have a wire coming in and out. I did a video explaining some power quality metrics. There's a link below. In general, I will just state what is good and what is a bad number. Let's plug it in and check out the idle consumption. I'll give it a minute to settle out here. So first looking at the idle power and VAN, and it isn't great. The power factor is very poor at 0.09, but this is at less than 1/10 of a watt. So the results are fairly mixed. Good THD, which we'll see later, probably because some extra room and AC line filtering for the larger space of the USB portion. Means it can basically filter the signal a little better. So compared with a small USB plug adapter, this thing has some benefits. Side effect of that filter is that it actually uses a little more continuous current though. Here we can see an ultra-low test load connected and the resistor directly across the output, and the device starts to use a little more power when it has some load connected. Let's turn the heat up a little. 15 watts on the USB-C port, no problem. 16 watts? Sure. 17 watts? Nope. Reached overcurrent protection on the USB-C port at 17 watts, which is a reasonable margin. This device does not have any power delivery specification, so again, only 5 volts on both ports. To get the full power out of this device, I had to swap ports. The USB-A port is where problems begin. This port is not overcurrent protected, so it will deliver the full 5.1 amps into the output. USB-A connectors are not designed to carry this kind of current, nor the cables. So this is a little dangerous for this wall socket to operate in this range. The cables and the socket will get quite warm. There are some USB-A sockets rated for 5 amps, but at this point, we'll be dissipating about 1 watt in the connector, so this isn't a good choice. And these parts are about $2 each in quantity for only the connector. And this is also a gold-plated product. This does not have that. The others that are available in the market are typically 3 amp rated at best and are really designed for short-term 3 amps. And these specifications are bumped up. Most typically you'll see 1.8, 1.5, 2 amps, that kind of thing. USB-C, on the other hand, can negotiate more current, and power delivery modes up to 5 amps exist. So it looks like this is almost backwards. When doing 5 amps, you do need to make sure that your connector and your cable can actually handle that. And there's supposed to be labeling for those specific cases. In either case, it can deliver 15 watts to the USB-C port, or 25 watts to the USB-A port, or 15 watts to the USB-C port and 10 watts to the USB-A port, which is probably how it should have been limited. So to test both loads simultaneously, I am using a less accurate USB meter to set the extra load on the USB-A port. This device is good enough within a couple percent of the Siglant load tester. This is to test how the device recovers in an overcurrent situation. So with 15 watts on the USB-C port, I added in some load on the USB-A port. At about 11 watts, it trips protection on the whole system. Interesting, this also trips the USB-C circuit. When this happens, the USB-C circuit does not recover. Only the USB-A circuit turns back on. The load has to be removed from the USB-C circuit and reapplied to the output to turn it back on. So the topology of this design leaves a lot to be desired. In terms of overall results, this isn't a bad performer. It has an interesting efficiency curve since it seems to perform a bit differently with the USB-A port versus the USB-C port. It has good THD at light load. Again, suspicion of the extra filtering due to the extra space available inside the device. Does anybody want to see a teardown or analysis of the inside of the device? If you want to see a teardown, leave a comment down below. Overall, we can see the highest performance from this device happens around 10% of its rated load. This is unusual. At 100% load, the device climbs back to decent performance though. Under these higher loads, the power factor and THD are not amazing, but the high efficiency for the real power is making up for some of that. In summary, this adapter is adequate. I know there are better options already, and they're going to be in future videos. Here's a summary of the USB-C power adapter so far. As we can see, the Eaton isn't too bad. It isn't as good as the Encore, but it's getting fairly close. The high VA usage on idle and the lack of overcurrent protection are the major drawbacks. The overall power is higher since it's a higher power class device, but in general, power quality is not bad. On a graph, the lower THD helps make the idle power quality, and low idle power consumption puts it towards the top of the list. It broke free of the cluster of other USB adapters. Under load, this device also fares quite well. If it had better management of the current between the two ports, this would be a solid all-arounder for moderate speed charging at least. But with the lack of proper protection on the USB-A port, I can't recommend this device. Thanks for watching. The best way to help creators like me is to share our content with others. Join me for another video in the near future, and as always, like and subscribe. 3 more of these to go, and I found that 15-watt adapter, maybe a short video on that. Thanks again, and bye.